It's getting pretty hard to keep ignoring this whole AI thing. While writing this script, I talked to many friends both in and outside of the software industry, and I expected at least one person to say, yes, it's probably a dying craft. But I didn't. Granted, I'm not friends with the CEO of NVIDIA, so it wasn't a completely representative sample. People who have learned to program, whether they use it in their job or not, generally don't think it's time for beginners to stop learning. This video is going to cover why. Like every software company on the planet, we recently released some new AI features. At first glance, they might seem fairly tame. We're even looking into disabling AI features for beginners at the request of our community. During a time when many companies, including JetBrains, are embracing AI for developer productivity, the choice to keep our courses AI minimal might seem strange. Shouldn't students be learning to work with these tools from the beginning? Shouldn't the newbies be adapting to our new AI world? I mean, if I'd grown up with AI in my pocket, I probably could have learned C in 48 hours. Scratch that. C and JavaScript. They're not that different. Our choice to move slowly and thoughtfully with regards to our educational AI features is intentional. It's not an oversight. If we wanted to, we could build all these fancy features. The reason that we aren't is that we are listening to our incredible educational research team. We do recognize that LLMs can be very useful to aid understanding of new concepts, but we also think it's important to understand how these tools help and hurt learners, because there is good evidence that they have the potential to do both. Let's start by talking about the worst-case scenario. The doomsday AI that spells destruction for most of the jobs that coders have today. People who are less skeptical about technological advances see this as inevitable and coming soon. It will mean that any website, product, database, etc. can be sufficiently created, adjusted, and maintained by someone with no deep technical background. Well, even in this future, programming is still an excellent exercise in a specific kind of thinking. And it's not clear that the need for that specific kind of thinking is going to go away even with advancements in AI technology. In learning to solve problems computationally through these little introductory puzzles in Python, we begin to see the world a little differently. Our digital worlds become demystified. We see concrete problems where previously there was just a vague feeling of frustration or discontent. What's even better is that we also learn to see both these problems and their computational solutions. In learning to program, we gain new ways to make positive change in the world. You start to really notice how software could be made better. You feel more agency and power in making it better. You can even bring these coders' eyes to the physical world and notice a daily inconvenience that might be solved by a simple program. This specific kind of thinking and seeing that you develop when you learn to solve problems with code is aptly named computational thinking. And I think it will be a good skill to have for as long as humans are interacting with machines, no matter how capable the machines claim to be. Taking a more grounded view of AI development, it's safe to say that no matter how good the machines get, their adoption is guaranteed to be a long and messy process. Success in navigating this ever-shifting landscape will depend on your ability to adapt to new technology, and robust computational thinking skills will make that process much easier. I don't know if you've noticed, but in the history of computing, the meaning of the job programmer has evolved from doing complicated math by hand, to punching machine code into cards, to writing assembly languages, and then high-level languages, not to mention adapting to new IDEs and general tools like Git. Learning from history, we see that the tools always change, but the opportunities for people with technical knowledge and high-level reasoning skills continue to flourish. If you're a beginner who's plagued by the feeling that writing all these if statements by hand is a waste of time, I hope this idea can bring you some peace of mind. In the short term, you'll still need to know how to program well. Most experts expect AI to augment many developer jobs, not completely replace them. Although AI-generated code is becoming increasingly prevalent, skilled people still need to review, debug, and take accountability for the quality of said code. How much of a technical foundation will you need to be able to do that? Well, the safe answer is everything a traditional coder knows. Smart organizations are willing to pay for this level of expertise because ultimately, deep knowledge and experience serve as risk mitigation in the face of evolving technology. If you hire someone who can only code with the help of AI, then the current state of AI is the limit for how good your code is. If there are predictable vulnerabilities and mistakes in AI-generated code, then you're stuck with them. So, Have I convinced you that it's still worth learning to code for the sake of our collective employment opportunities? I hope so. Now, the obvious next question is, where do you start? Take it easy with Python, go deep with Java, keep it visual with web development? Honestly, my hot take is that it doesn't matter. The important thing is to just start. Write code. Good code, bad code, it doesn't matter. Start with something that actually interests you. Find ways to make the boring stuff fun, or at least less boring. If you're looking for a place to begin, JetBrains Academy has free courses you can do right inside your IDE. So, learning to code is still useful, but isn't it super difficult? You can check out my video about what makes programming seem so hard and what to do about it. Please subscribe and share and comment if you enjoy these videos. That's all for this one, and enjoy your learning.